Welcome to the Digital Enterprise Society podcast, addressing all aspects of the digital enterprise, inspiring connection without boundaries and creation without limits. Thank you for tuning in. Here are your hosts, Thom Singer and Craig Brown.
Hey, and welcome to another episode of the Digital Enterprise Society podcast. Thank you so much for coming along on the journey of this show that we started well over a year ago now, with the idea of being a resource for those who work in and around PLM. The Digital Enterprise Society, it is a forum for the exchange of ideas surrounding the tools, processes, and practices used across the product lifecycle. To learn more, visit digitalenterprisesociety.org. My name is Thom Singer, and I have the honor to co-host this show every single week, and I co-host it with Craig Brown. Craig is an industry veteran and former PLM leader at General Motors. Hey, Craig, how are you today?
I'm good, Thom. It's good to hear your voice as always. This is a pleasant part of my week because, you know, in these times, it's good to hear a friendly voice. So it's nice to hear you again.
You know, I was telling my wife, I so look forward to talking to Craig every week, and I don't even know why. It's just fun to do this show every single week. And today, our guest, sometimes if you listen to the show often, you know, Craig and I banter about Michigan versus Texas, just in general, as like a place to live. And we all know that that's not even a competition because I live in Texas. And today's guest, where does he live, Craig?
In Texas. I have to give in.
Today's guest lives in Austin, Texas, not too far away from where I live. And every single week, Craig and I try to bring to this show really interesting interviews and other ideas that are going to help our listeners enhance and grow their careers. And today is exactly what we're going to do. We have with us today Chad Jackson. Now, Chad, what he does is he conducts and publishes research on advice for engineering executives, which, hey, a lot of you who are listening, you are engineering executives, or that's where you're headed in your career. So we thought we would chat with Chad about the industry and some other tidbits around career advice. He is with a company called Lifecycle Insights, where he is the chief analyst. Hey, Chad, welcome to the Digital Enterprise Society podcast.
Thanks so much. Yeah, I appreciate you guys having me on, Thom and Craig. And I'm looking forward to the discussion. This is going to be fun.
And it's always good to have a neighbor on the show.
There you go. Absolutely. Especially
Wait a minute, guys.
So,
no, the Big Ten is trying not to spread the disease, though the former Big Ten coach got it down in Alabama. But
meanwhile, in Texas, we're playing football.
Well, we will be shortly, but goodness gracious, isn't it terrible? We're not playing football in parts of the country. I'm talking about college football. So, anyways. Okay, neighbors.
I was just going to say, we probably should include Craig in the conversation here. But Chad, before we get started, can you tell us a little bit about your background? What did you do early on in your career, and what led you to what you're doing now?
Yeah, sure, absolutely. So originally I'm from Kentucky. Went to the University of Kentucky and mechanical engineering, and joined PTC. I worked at PTC for, I guess, over a decade. And then I went to the Aberdeen Group. I wanted to get into research. Had the opportunity to go there, and I was there for a few years. And then in 2010, I started Lifecycle Insights. Started doing my own thing, and it's been a blast. Loved it ever since then.
Interesting. So the words can lead me to all kinds of questions. So let's start with your surprising insight. Maybe your motivation for wanting to be a researcher rather than a builder. Like, you know, PTC is one of the big PLM vendors. What was it that drove that decision?
Yeah, well, you know, I was working on campus at UK and had the opportunity to use Pro Engineer. This was back, 93, 94, 95. And really, I just really enjoyed being able to model in 3D. And then, years later, I got into product management, being able to drive the decisions and enhancements around parts of Pro Engineer, parts of Windchill. And I really, I became fascinated with this idea of, hey, we should really gain insight into what's going on in the industry. And that should drive decisions around investments and enhancements to all these solutions. But then it grew beyond that a little bit more to say, well, technology is a piece of the answer. A lot of time these executives, actually the technology sometimes is the easiest thing to address.
Yeah, a lot of people don't realize that.
Yeah.
I mean, there was a time when it was really expensive. About the time you were in school, the PC revolution took off, and all of a sudden, all these tools are moving from some expensive mainframe or high-end workstation,
Yeah.
and they're migrating to your laptop now, right? So, yeah, wait, so you just decided to do research. So what's your research telling you? What are let's be positive. What do the really good companies do well when it comes to things like digital enterprises?
Yeah, so I think one thing for sure, I guess there's two kind of key components that I've seen is number one, the companies that are doing well are proactive, right? So
Okay.
too many times companies wait for this impending event or a catastrophe, a really bad experience before they change, right? And by then it's too late. So companies that are kind of proactive and take it on early are ahead of the curve. The caveat to that, though, the second thing that really good companies do is they realize that these initiatives, you can actually disrupt yourself if you do it wrong, right? So you got to be careful, right? It's not, you can't just throw caution to the wind and just dive headlong into a change. You need to understand, especially for your company, different organizations have different appetites for change and comfort with change. So you got to be very aware of that and understand, well, how is this going to work in my organization? That's what's key.
Yeah. So let's talk about the negative side for a second. So what in your research are there common patterns to what fails? I mean, is it just ignorance? Is it organizational resistance? We've talked on this show about something called Conway's Law, which basically says tools or organizations start to mimic each other, right? And then once the organization's in place, it doesn't want to change, right? So it won't adopt new tools.
That's true. Yeah.
But yeah, what are the negative sides of this? What seems to be the pattern?
Yeah, so I think one of the patterns, a negative cycle, is not recognizing that, frankly, politics play a big part in this, and not not the political season we're going through now, but more organizational politics. And different leaders have different interests. Like I always contrast, there's often a leader that runs the initiative that's been tasked by a higher level executive. Okay, go make this successful. And yet the functional leader, the person that is in charge of engineering, they already have, often a really tight schedule, limited resources. And the person leading the initiative might go to the functional leader and say, hey, we're going to make this change and it's going to be great. And it might take you guys a little while to get up to speed, but it's going to be great in the end.
Right.
And the functional leader looks at that and goes, what are you talking? You're crazy.
Yeah. Not on my watch.
You got to be out of your mind. Yeah, exactly. You're introducing risk to my plan. And
so when you see that, what advice do you give them? I mean, you tell them to go out and do kumbaya, or do you tell them to do something well together, not apart, right?
Yeah, I think it's really important for all of the leaders, and there are lots of different leaders. There's a financial leader, there's an IT leader, there's the business leader that often wants to drive this for economic reasons. They need to get on the same page. Like the functional leader needs to clearly articulate, here are my constraints. And man, if I miss them, this would be a failure for me, right? And the initiative leader needs to clearly explain, okay, these are my goals and objectives. This is what's important to me. And they need to come to, I know this is a dirty word, but a compromise around the scope of what needs to change, how they're going to work together to realize it.
About the time you started your business, General Motors went through a very bad financial time and actually a bit of bankruptcy and so on. And I started a renewed, really, because other people have done it before me, a PLM governance group. And one of the things I learned, and I was blessed with senior leadership all the way to the top, that was saying, yeah, we can't keep operating like we used to. We have to be different, and we have to look for benefits. The first thing we did is I didn't show up with, here's a new thing, it's going to be great for you. I said instead showed up with a governance structure. I actually learned this from another industrial giant. And I said, this is your role in the governance structure. Oh, by the way, all investment in where we're going is coming through us. and so we had a shared domain, if you want to say that. And, we had vice presidents in there across the enterprise. It was quite interesting to watch how that evolved. And what you pointed out, what happened all the time? Well, I'm not measured that way. And that doesn't meet my metrics. And we were able to take that back up to, the person in charge of engineering and say, well, put them on common metrics. The sooner we get to common measures, the sooner we'll move forward together. And to my pleasant surprise, they did it, right? And so, the General Motors of today versus the one of 2010 is really quite different. And that was the beginning of that different culture, at least from my vantage point. So you talked about the four topic areas, and I want to make sure we touch on each one. And let me start with systems engineering. There is, as you pointed out in your email to me, quite a buzz about it. We've talked a bit about it on this show, but you also cautioned, adopting the effort itself can be complex. What are the most important lessons you've seen? And maybe if you've seen it different for large companies versus small, one of the things we're trying to do in the Digital Enterprise Society is help those medium and small companies. The big boys have been at this for a while. So what lessons do you have for them? What advice would you give them when they're going to start adopting more systems engineering?
The first thing, well, I guess one of the key things that I would suggest is be keenly aware of the scope of what you're going to take on. Okay. Because systems engineering, frankly, it's a mindset. I mean, we've kind of expanded our coverage. I don't know, 2 or 3 years ago, from just kind of focusing on mechanical hardware to more across many different disciplines. And it struck me like the key, like this difference between mechanical design and electronic design. In electronic design, you develop this logical layout, logical design, and then a functional design, and then you get to physical design, right? But then you look at mechanical design, it's like, okay, I see a problem, and the gears turn inside your head, and it figures out what the solution is, and suddenly you're documenting it in 3D CAD, and you skip that logical and functional. So there's this bridge, you got a gap, because system engineering, there's requirements, logical, functional, and then physical architectures.
So when you were in college, why don't they teach logical design? Thanks for laughing, because this is a problem, right? Why don't they teach logical abstraction to mechanical engineers? I mean, I find this is a common problem, right? And then when you tell them to talk about systems engineering, I remember a debate I had. It was not with PTC or Siemens, it was the other one. And I said, well, we don't do logical. And they said, what do you mean? And I said, well, everybody knows what a car is. It's got 4 wheels. It goes down the road. It probably has 4 seats. And, so this notion of partitioning and logical balancing and other things like that, it's true, you don't need it, right? Or at least it seems like a waste of time because you know what you're going to do already. Well, the recent advance of bringing electrification back to vehicles, I mean, it was there originally. You absolutely need a logical model. You got to just decide how you're going to do power management and how you're going to do battery charging and how you're going to do range if you got, yesterday's battery technology instead of tomorrow's. So a logical model is really needed. Now, I like the other thing you said. It's really a mindset. A lot of people think system engineering is a discipline. You said it's a mindset. I kind of like that. Can you expand on that? Who does it? Is it just a certain group of people or is it everybody?
Well, it's it's pretty fascinating. If you go to any systems engineering conferences, they have developed this process, frankly, that could be applied to almost any problem, in any level of complexity. And it has a way of abstracting things. What is a requirement? What's a function? What's a entity in a logical architecture? And we all know what the physical items are, right? That's kind of the end thing that you get to. But you got to be able to, number one, be able to step back and abstract these things, and also not proceed too far. I think it's funny. I think as engineers, we're naturally problem solvers. So we want to get to that physical item because that's like the end solution. But when you're developing requirements, it's really important, if you do it right, to write them so abstractly that they're open to many different solutions, not just the one you have in mind.
And
So
I think that's really hard for people to do if they weren't trained that way.
right, really hard.
There are certain engineering disciplines, chemistry is one, aerospace engineering is another one, where you were purposely broader because you had to be to integrate all those other systems, right? It's been interesting. Even I'm an aerospace engineer, but I've had interesting debates with my electrical counterparts, who a lot of them want to be cookbook. I just want to know which components to glue, solder together, and off we go. And the whole abstraction layer of, well, do you do it with this kind of digital circuitry or the other kind of, they lost that as they got into to a company. And I think if a company's a niche, and this is part of the probably challenge of a small company, is if they're very much a niche component, it's just going to fall on deaf ears that, no, you got to learn to abstract and then you'll be better at system engineering, right?
Yeah, that's fair. That's very fair.
So let's go a little deeper. So you mentioned this electricals and embedded software and how it's getting into more and more products. Is this, you mentioned cultural changes, and what I was trying to understand in your comment is, well, is this across the disciplines or is it within the disciplines? So a discipline being mechanical or whatever.
Right. Yep. I think that it is across disciplines, and it's interesting. I think we're entering an era of design where system engineering actually needs to become a little more specialized. The abstraction is okay, but for example, if you look at EE systems, electrical electronic, that actually encompasses software as well now. There are decisions that you can make in the architecture, the electrical electronic architecture of a car that has dramatic impacts across the system, right? If you shift a function to a different ECU,
right,
and the software goes over there and it's a module, well, maybe you just overloaded the network.
Right. You got to know that. You should know it up front.
Well, here's the key. You're going to find out sooner or later. It's just, are you going to find out when you start building the prototype? Or are you going to find out in design, right? And there's obviously a benefit.
And gosh forbid you find out when it's already in the customer's hands. That's even worse, right?
Yeah. Exactly. So I think it's across disciplines is key. It can be applied within disciplines too, but I think the real problem that we're seeing today, where the amount of electronics and software and a lot of products is just exploding.
And that's not because they chose it. It's just because it's cheap, right? I mean, Moore's law and the fact that there was a time when we were all really, really careful about what kind of software, or more, I should say, how much software we put into a product, whether it's an airplane or a car. And now, because like your cell phone, I mean, my goodness, we've got oodles of memory and oodles of throughput, and so much so that the AI application in your phone is trying to figure out, based on what you and I are talking about, what to present you for dinner. right? I mean,
Right. Yeah.
it's insane. Yep. But I, that's where we are. The technology to do that is becoming very commonplace, and so it does make our lives better. I mean, that's the purpose of it. So,
Yeah.
so
Absolutely.
so let's go back to your roots, the mechanical design, and those other guys we just talked about are getting all the headlines, but there's still a lot of innovation going on in mechanical design. And you mentioned in your note to me that mathematical modeling is a key advancement. So first, describe mathematical modeling, and then tell me why it benefits us. Why is it so important?
Yeah, absolutely. This is an advancement that fascinates me, and I've been covering the industry for 20 years or whatever. So mathematical modeling. So basically, what this means in the simplest of terms is you can fill a volume with a shape, a cell. Think of it that way. But you can vary the density of that cell spatially, right? So let's say you're going along the x-axis of the part, and you want it to be less dense as you get further out. It becomes really interesting because suddenly you can change the function of that part, not due to its outside shape that is filled with a homogeneous material. Instead, you can vary the function of the part with this mathematical equation that you define, and the outer shape can be whatever, right? So it's interesting. So the lever that mechanical engineers have been pulling for the end of time has been shape, right? Homogeneous material, shape. Now, with both the mathematical modeling and being able to vary material properties spatially, which we can start to do that with 3D printing.
Correct.
Now, the shape can be whatever. It doesn't matter what the shape is. Instead, affect the functional properties through mathematical modeling or material properties.
So this could lead to not only faster engineering, but also very different options, design choices, right?
Yeah, it could. It could make it, lower cost. It actually could be way faster. I mean, think about all the time that engineers scrutinize and painfully go over what shape will be manufacturable and fit there and have the functional qualities you need. Now, if the shape doesn't matter and you use an equation, then okay.
Yeah, and to those of you on the audience who don't appreciate the depth of where Chad and I are going, there are shapes you've always wanted to make because it would be better for the product, and you don't know how to manufacture them. Now, with additive and especially changing this point you made, Chad, about changing the property as you put on layer after layer, and then you do the fine tuning of it with some kind of milling or sanding or whatever. It's really quite interesting. And there's a whole new set of dimensions that opened up. And, I think, right now, lot sizes of hundreds of parts are being made with additive or printing, right? For people that aren't following us, it's your laser printer printing metal instead of ink. It's really pretty amazing how this stuff works. And my point is you got to believe that the flexibility it brings will shorten product cycles, and that will make it into mass production places like car companies. It really will, and it's just a matter of time. And back to your point, mechanical design is all of a sudden a very important new horizon. You'll save weight. You'll come up with more reliable parts. Even fine tuning the center of gravity if you have to, right? If you're in an aircraft product or whatever. Yeah. So interesting.
Yeah. And by the way, real quick, I mean, there's the possibility to embed sensors and electronics in the middle.
Well, yeah, right. In certain businesses, certainly audio and cars and things that we care about the sound quality, having an extra microphone in effect or vibration sensor in key parts, you actually could make the product perform a lot better, right? you can avoid certain frequencies, and all of a sudden those thumps and rattles that you hear in a car go away, right?
Right.
Yeah. So, okay, so let me ask you one last question. We're in these times of the challenges of the pandemic, and virtual commissioning, whether it's just embedded software or everything through the electronics, or shucks, even include the mechanical system that it's actuating.
Mm-hmm.
From what you can see, is virtual commissioning becoming more comfortable, more aware, more in practice? Where is it on the journey? And maybe some examples of this.
Yeah, I think that I think this type of effort is following the normal curve for these kind of initiatives, which is, hey, the technology's got to get there first.
Right.
And the technology really is, I mean, there are some significant advances, to verify software will run on the target electronic hardware, and then that will actuate, the mechanical stuff the way you want it to. The technology is really getting there, and it's getting really strong. I don't think a lot of companies are really employing it today, unless they've had a catastrophe, right?
That's a good point.
Unless they're desperate, right? But I do think that is a new frontier where companies can really be more competitive. They can really accelerate time to market. So instead of sitting around for a prototype IC or a prototype board to actually build the prototype, you can instead do it virtually. And hey, when you do get that prototype, it works the first time through.
Well, if you take the big failures, right, the ones we all talk about too much, from a space shuttle and its reentry, the tiles or the O-rings that can't seal in cold weather, or there's car examples too, from sudden acceleration to ignition switches. If you take every one of those failures and ask yourself, well, if I'd have done visual simulation and showed the people making the decisions what might go bad,
yeah,
right? I'm especially thinking of Challenger, its launch. I mean, a lot of memos were written. A lot of people said don't launch because of the cold weather that day. And I'm pretty sure if they'd have just shown a video of gases sneaking around the O-ring and blowing up the main tank, there might have been a few more people say, you're right, we have to take all the political hits and delay a week, or delay till it's 50 degrees or whatever.
Right.
So I think visualization and virtual commissioning is here. And I think cloud technology and other things just make it really, really possible. To your point, companies are still uncomfortable. Regulatory agencies are also still uncomfortable, right? If you're in a car business, it has to be crash worthy, right?
Right.
So you still got to do physical crash testing, though most of the car companies do a fair amount of development virtually, but they don't virtually commission, right?
Yeah.
They still wait for that last physical sample to get the confidence. So it's interesting. Well, Chad, it's been nice to chat with you. We've run out of our time, so I'll give it back to Thom, and good luck. And if you have other insights, let's stay in touch.
Absolutely, yeah, and thanks for having me on.
Well, actually, Chad, I don't let you go quite that quick, because one of the things that I try to do on all of these episodes is I try to listen and I try to find something that we can go back to for the listeners, because we have a lot of people who are in our audience who are earlier and mid-stage in their career. They're sort of looking for opportunities. Because you do so much research and study around all this stuff, when it comes to career opportunities, what are some of the trends and opportunities that you think people should be looking for that they could take their career in a said direction?
Yeah, absolutely. I can think of two. I mean, I think one is systems engineering. We talked a lot about that. It's a way that, well, actually, let me back up. Companies are facing a lot of increased product complexity. A lot of them are turning to systems engineering as a way to mitigate that complexity. So they need help. Like, companies are looking for systems engineers to help to make sure that the prototype works the first time. So that's one. I think the other is, an investment you could make in yourself is to sharpen your skills around the inherent political nature of organizations. And we talked through it earlier today, but being able to understand what the goals and objectives are for different leaders, and not rail against it, not point to them and say they're the villain, but instead understand and find a compromise for them in the organization so that there's a win for everyone. I think those are the two areas where I think, it makes a ton of sense.
Hey, Chad, this is Craig. That's a really good point. And I especially in times like this where things are getting turned on their head and how you run a place, this is also a time you can find the really good companies, the ones that encourage that let's find a collaboration, let's find a way to keep moving forward, despite the fact that we're working now over 90% of the time away from each other, right? We're only able to do what we're doing today on Zoom, right? So I think I would add on to your advice, become more sensitive. And also, there's a lot of things changing. There's other good companies out there. The ones that do well in this crazy time are worth working for.
Yeah.
And they're all going to be hiring because they're all going through resizing right now, depending on which segment you're in. But they'll be hiring. There are people like me. We took the buyouts, right? And so there's going to be plenty of openings, and it'll all bounce back. We will get through this period. 2 years from now, we'll be starting to see each other face to face, maybe sooner. And and I think people should take this opportunity to learn, watch, observe. It'll be really good.
Yeah, agreed.
Awesome. Well, again, Chad, thank you so much for being with us. If someone wants to know more about you or about Lifecycle Insights, where do they find you?
Lifecycleinsights.com. That's simple.
As I say, that was easy. All right.
I thought he was going to say Austin, but never mind.
That's right. You can find him out by the lake, apparently, in Austin.
Okay, whatever.
Awesome. All right. So again, thank you for being with us, and thank you to everybody who tuned in and listened. Remember, we want you to join us every single week for more thoughts, ideas, and information in and around product lifecycle management. The Digital Enterprise Society, it is the place for the exchange of ideas around digital manufacturing tools. Check us out at digitalenterprisesociety.org.
You've been listening to the Digital Enterprise Society podcast. Learn more about what you've heard here today at digitalenterprisesociety.org. Join us again next week for more connection without boundaries and creation with